All right, we're going to look at how do you graph logs. And we're going to start with just basic log functions. When I say basic log functions, y equals log base b to the x. There's no transformations. We actually will look at some transformations a little more complex later. But if you have what we call, this is just like sort of like a parent function here. Okay, if you have log base 3x, how does the graph look? In order to get a good idea of how to graph something like this, let's change this form of this and let's go ahead and put an exponential form. So if you look at this, what exponent goes on 3 to give me x, and this is my exponent. So what exponent goes on 3 to give me x, well that is y. So if I look at a chart of values and how these look, it's a lot easier when I'm doing something like this. Instead of putting your x values in front of y is, I'm going to put y values over here and say, all right, if y is 0, if y is 1, what are my x values? Okay, so I can put 0 in, anything to the 0 power is 1. Okay, and then I could put 1 in, 3 to the first power is 3. So those would be some points I can graph on this function. And if I plot these points, there's 1, and I go over 3, here's where they'll be. So now how does this graph look? Okay, next thing I gotta think of is, what is my domain for this? Looking at this, if I have 3 to any power, okay, will it ever be negative? Well, no. Okay, if you could put negative exponents in, you could put negative 100, and you're gonna get a very, very small number. It'll be 1 over 3 to the 100th power, which will be very small and very close to 0, but it's never gonna be, okay, a negative. It's never, so it's always going to be the values, x always has to be greater than 0. When you have something like that where it gets closer and closer to 0 but never gets there, we call that an asymptote. So if you look over on our graph, I know I'm going to have an asymptote right here, where this graph's going to get closer and closer to it but it never touches. Right, so that's the thing you'll know. And I know domain has to be greater than 0, and I say my VA, which is vertical asymptote, is x equals 0, because that's what it gets closer and closer to. Knowing that then, and knowing these 2 points, here's what the graph of a log is going to look like. Because this will get closer and closer to 0, so this gets small, it goes down and down. And over here, it's always going to increase, okay, because once again, is this value, if you look at this, okay, as this value gets larger and larger, you know, again, if I put larger and larger values in for x, the exponent's going to get larger and larger as well. So it's always going to go up to infinity. Okay, so that's the basic thing. Now, for all graphs, if you could at least remember, once again, x can't be negative. So if I was going to graph this one, for example, I know I'm going to have an asymptote here. And I can do this chart, but I could pretty much get this pattern that anything, no matter if this is 5, 8, 100, anything to the 0 power is 1. So I know pretty much all of these basic functions where there's no transformations, it's going to go through the point 1, 0. And then another thing I know is if I put 1 on here, I'm going to get whatever that value is. So 5 to the first power is 5. So points I can always graph are 1, 0, and I can go all the way over here to b, 1, which in this case is 5, 1. And if you need to make your chart, you can sort of see, because once again, if I change this to exponential, this would be 5 to the y power equals x. And once again, I put these in, 0 gives me 1, 1 gives me 5. So anytime you have these, you know that you're going to have the points 0, 1, and whatever your base is, sorry, I wrote that backwards, and b, 1. And then you have your asymptote. You can go ahead and fill in the rest of the graph. All right, so if you look on that worksheet, you have 2 more graphs to complete below that, and then you can move on.